The Physics of Sound and Music, Doc here with you for critical thinking and closed pipe harmonics. We're going to go to the Silver Bullet review for exam 2, and we're going to look at how we can remember the closed pipe harmonics chart from the open pipe harmonics chart, which, by the way, this chart is the same for the string. Well, to get the closed pipe harmonics, we cross out all the even harmonics and replace 2L with 4L, and we're finished. That's it. Notice that the same principle applies here. We let F be the fundamental frequency and go from there. So the third harmonic is triple, the fifth harmonic 5 times, the seventh 7 times, and for the wavelengths we divide by the numbers 3, 5, and 7. So we're going to give here you the same length as we did for the open pipe in the previous video, where we have 30 centimeters. For the closed pipe, we simply close one end. We cap the open pipe to get a closed pipe. And what would be the wavelengths for the first 4 cases? These are our first 4 cases for the vibrational modes in a closed pipe. If the length is 30, we go to our chart that we memorized, the result 4L. 4L is the first one. So 4 times 3 is 12. 1 0 hangs around. The answer is 120. So 30 times 4 is 30 times 4, and that is 120. 120 centimeters. To get the next harmonic, the third one, because it's odd, the even one is not present, we need to divide by 3. So divide by 3, 4L, this is 4L here, divided by 3. 3 into 12 is 4. The 0 hangs around, and we get 40 centimeters. To get the next case, which is the fifth harmonic, because we skipped the even ones, so we skip 4, then we want 4L divided by 5. Well, here's the 4L. It's 120. Divide that by 5, which we can do with the shortcut. What we do here is we consider giving $120, splitting it up for 5 folks by splitting the $100 first and then the 20. So if we write the 120 as 100 plus 20, then we split the 100 up first. That gives $20 per person, and then we split the 20. That gives $4 per person, and they add together to get 24 for those 2 amounts of money. We can also go to the master formula, which we know from here is 4L over 5. 4L over 5, L is 30, so 4 times 30 over 5. And instead of multiplying the 4 times the 30 to get the 120 to be in this situation, why not simply divide first? When you have numbers you're multiplying and dividing, you can do them in any order. So we divide 5 into 30 first to get 6, and then 4 times 6 is 24. For the 7th harmonic, which is the 4th case for the closed pipe, it's 4L over 7, and that one here is 120 over 7. That one doesn't divide out easily. But for a side little discussion, we can approximate that using the trick here, where we look at the 120 and split it up into 70 plus 50, because 7 into 70 goes 10 times. And then the trick we used with the triangle wave for one of our homework assignments, when we had 1 over 49, we said that's like 1 over 50. So 50 is approximately 49, so the little squiggly equal signs means approximately, and we get 7 into 70 is 10, 7 into 49 is 7. This is roughly 17. What about the frequencies? Well, that requires us to look at consistency with the velocity of sound, which is 340 meters per second at room temperature, but I'm going to put this pipe in a hot room like I did for the open pipe, where the speed of sound is greater. It's 360 meters per second. And in centimeters, well, since 1 meter is 100 centimeters, we multiply this by 100 to get the centimeters per second. And by doing that, I add or tack on, so to speak, 2 more zeros. When you multiply by 100, you tack on 2 more zeros. So here you have 1 0 plus the 2 more tacked on because of the multiplication by 100. You have 36 with 3 zeros. You have 36,000 centimeters per second. To get the frequency for the fundamental, we have the wavelength. The wavelength times the frequency is the velocity. And if this velocity happened to be 6, and you had 2 times 3, you would get the 3 if that, or you happen not to know it, you would get it by dividing the 2 into the 6 to get the 3. So we have the 120, we have the 36,000. We want to know what the F is. We divide 120 into 36,000. This 1 0 cancels, and it's 12 into 3,600. 12 goes into 36 3 times, so you have 300. 2 of the zeros hanging around. Then to get the other frequencies for the other cases, the 4 cases, we have here, see 4 odd numbers, 1, 3, 5, and 7. We then multiply. Consider this 3 as the base. Forget the 2 zeros for now. Then we are looking at 3 as a base. This is our math facts. This is our multiplication table to have handy. Study this from time to time to refresh your memory on what these values are. So 1 times 3 is 3. 3 times 3, 9. 5 times 3, 15. 7 times 3, 21. So doing that here, 1 times 3, 3, 2 zeros hanging around. 3 times 3, 9, 2 zeros hanging around. 5 times 3, 15, 2 zeros hanging around. And 7 times 3, 21, and 2 zeros hanging around. Notice that if you multiply any of these wavelengths by its corresponding frequency, a pair here, you will get the same velocity, since the velocity is dependent upon the properties of the hot air, of the gas, the medium through which the sound waves travel. Now we know the first one will work out that way since we use the formula to get this. 3 times 12, 36, and 1, 2, 3 zeros tacked on, 36,000 centimeters per second. Let's try the next one. 4 times 9, 36, and 1, 2, 3 zeros tacked on, 36,000 centimeters per second. The next one here looks a little too cumbersome to multiply out, so we'll go to this 7th harmonic, the 4th case in the vibrational modes of a closed pipe. And here we can divide 7 into 21 first to get the 3. 3 times 12, 36, and 3 zeros hanging around, 36,000 centimeters per second. What about looking at a problem that we can give you here where we're going to work out the answer pretending we don't know this whole thing. We just give you here the 5th harmonic frequency is 1500 hertz. Can you find the 3rd one? Well, what you would do is reference this back to the first one. Remember, we got this by multiplying 5 times 3 to get the 15, the 2 zeros hanging around. So to go backwards, you divide by 5. 5 into 15 gives you 3, the 2 zeros hanging around. And then you go up to the 3rd harmonic by multiplying by 3 and get your 900. Well, suppose we have a configuration here without the H3. You see a picture on the exam, and you want to know what the frequency is, or say the wavelength. Well, here's a neat way to do it. Count your vertical lines. 1 vertical line here, 2 vertical lines, 3 vertical lines, and 4 vertical lines. These are your 4 cases. And you have dashes in the other places. Always have a dash at the far right, by the way, the open end. What do these vertical lines cases mean? Well, 1 vertical line means the first odd number. Now, the first odd number is 1. And 2 vertical lines, the second case, means the second odd number. Well, the second odd number, well, that's 3. See, 1, 3, 5, 7, 9, 11. These are odd numbers. So when you go to the 3rd case, 3 vertical lines, it's the 3rd odd number. Well, that's like 1, 3, 5. It's 5. And then 1, 2, 3, 4. The 4th case is the 4th odd number. Well, that's the one after the 3rd odd number. That would be 7. And the next odd number, which would have, say, 1, 2, 3, 4, 5 of the vertical lines, that would be the 5th case. And that's the 5th odd number, H9, and so on. So this is the 3rd harmonic, and that means, being the 3rd harmonic, we know from what we have studied that the frequency will be triple compared to the fundamental, and the wavelength will be obtained by dividing the fundamental wavelength by 3. So if you give me the 300 hertz for the fundamental, I know this will be triple the frequency. It'll be 900 hertz. If you give me the 120 centimeters for the fundamental wavelength, I know that the case here is the 3rd harmonic, so I would divide by 3 and get 40. If you give me the length L is 30, Then what I would do is I would use the formula for the third case, 4L over 3. And 4L over 3, I would divide by 3 first, get 10, multiply by 4, and get my 40. So that is how we can do closed pipe physics. Note, by the way, that when you go from a vertical line to a dash, that's 1/4 of a wave. So 1/4 here is fitted to L, which means that the wavelength is 4L. Which we have memorized from our chart. I just wanted to point that out, sort of derive it for you there again as a review. One last thing to consider here is the idea of capping a pipe. If this pipe has an open end here, it's an open pipe, and you may recall from the previous video that we had a 60 here and a 600 here. When we cap the pipe, we drop down an octave. So the 600 from before becomes 300, and when you drop the frequency down by a factor of 2, in other words, you drop down 1 octave, then you must double the wavelength. You must do the opposite thing to the wavelength. Divide by 2 on the frequency, I multiply the wavelength by 2, so the velocity stays constant. And by looking at the 60 we had before, when you multiply the wavelength by 2, you get 120. So a nice little comparison of the closed pipe and the open pipe, where you have the same length for each.